Hello, and welcome everyone. I'm Rajesh Vishwanathan from the Cloud Native Services team at Oracle Cloud Infrastructure. I'm very excited today to talk to you about simplifying modern app development to design secure, resilient, and scalable apps. We have a lot to cover today. I'll start with describing how application development today is a far cry from what it used to be, with so many different requirements and some of the challenges that this creates for developers. We'll then detail the set of requirements that any modern app needs to fulfill. In fact, it's these requirements that make it a modern app in the first place. And then, we'll spend most of our time today talking about what we at Oracle have learned building these types of apps ourselves. We have crystallized these learnings into 10 design principles that effectively represent our opinionated guidance for any developer who's building a modern app. So let's get started. So app development today has a dramatically different and new set of considerations than a few years ago. Apps are expected to deliver feature improvements quickly and continuously. They're expected to be priced more elastically. The security bar keeps moving up, and scale requirements have increased by orders of magnitude. So what this has meant is that developers are doing a lot more than designing and developing the core functionality of the app. They have to familiarize themselves with new development methodologies and frameworks. They have to think about how to support expectations around more dynamic pricing, around evolving security and compliance standards, and finally, how they can incorporate newer technologies that are available through open source ecosystems. And of course, they have to do all this while they continue to have a strong posture operationally to meet their massive scale requirements. So all this means that they're spending far less time actually coding app functionality. In fact, developers that we've surveyed indicate that they're spending less than 20% on the actual functionality of the app. It would be great to improve on that. So let's step back and consider the core requirements for any application today. Regardless of what the app does functionally, these 9 requirements need to be met anyway. So first and foremost is security, and generally very closely related to security is compliance. It is critical to ensure that appropriate policies are aligned with industry best practices and they're enforced at all layers in the stack. You have to ensure that you're thinking about confidentiality and the integrity of the data your app uses. And then in order to ensure that the app is compliant with any of the various compliance standards and guidelines, those policies must be included and enforced as well. Next up, availability. Most customers expect your app to be available 24/7, 365. No downtime, not even planned downtime ideally. Let's talk about scalability. Your app needs to scale from tens to thousands to millions of users and handle increasing volumes of data without needing to redesign the app. Performance. Your goal is to provide the lowest possible latency and highest possible throughput for the best possible user experience you can give your customers. Agility. If you think about it, agility is perhaps the most important driver of the modern app paradigm. You have to keep up with customer expectations of how quickly they can get the latest feature. So you can't really be bottlenecked by manual processes in the build and the development cycle of your app. Observability. You should be able to monitor all aspects of your application: uptime, latency, performance, etc. Your app developers should have alarms set up that go off when thresholds are breached on any of these KPIs. Let's talk about resiliency. Regardless of everything you do, there are bound to be situations that risk your app's availability or your app's performance, or even worse, the durability of your app data. So it's critical that you build in resiliency from the get-go. You have to ensure that the app can recover gracefully, and you have to make sure that you're designing to prevent data loss. Cost optimization. There's a lot of requirements here, and you're making a lot of choices to support those requirements. You have to be intimately aware of the costs involved here and optimize to drive that down. And finally, portability. Ideally, your application should be portable across various runtime environments. So what that typically implies is that you leverage open standards or open source, because that tends to have a high degree of familiarity to developers. You really don't want to make design or technology choices that limit how easy it is to ramp up new developers coming onto the app. Okay, now that we understand the requirements, how do we go about fulfilling these? It turns out that the problem here is there's almost too broad a set of choices and decisions that developers and architects have to go through as they think about how can they meet these requirements. And of course, you would rather they spend this time in developing the actual app's functionality. So we can simplify the decision-making around these requirements. The developers and the app architects can get that time back. At Oracle, we've thought very deeply about these challenges, and we've arrived at a set of 10 design principles that guide both how we think about our own applications and the services that we build that our customers build their apps with. So our goal with these design principles is to benefit developers to focus on coding the app, and just by using the technology recommendations associated with these design principles, meet the core requirements that we identified earlier. So here are our 10 design principles to develop modern apps. These principles cover the entirety of the application lifecycle: how you develop, build, package, deploy, secure, and operate your apps. So in the next few minutes, we'll talk a little bit about each of these. Why are they important? How they help? And specific technology recommendations aligned with each principle. So let's get started. So our first principle focuses on how you develop your apps. Use lightweight frameworks and mature programming languages. So the programming language, the library, and choices that you make around a framework, the patterns you adopt to build your app, these are very critical in defining the maintenance costs of your application over time. The languages, the framework choices have long-term impact on how are you scaling your business, how are you operating your applications, and how are you delivering those high-quality features to your customers. If you make changes in these choices, you're incurring a high switching cost. So in terms of language, mature languages with mature ecosystems are going to prove far more dependable than newer ones that tend to have a high change rate, both in the design and in the ecosystem of the libraries that are involved. The application framework you pick should ideally be able to provide sensible, non-controversial defaults for common things like logging, telemetry, security, configuration, and should also provide you common patterns. An example of this would be building a REST API. That should just be built into the framework. So our recommendations are that you should use Java as your language choice. Java is obviously an incredibly mature language. It's very stable, and it's a very broad set of capabilities that covers a wide swath of app use cases. It also has a very healthy ecosystem of libraries and frameworks. For the JDK, use GraalVM to develop and run your apps. So this allows you to combine Java stability with best-in-class performance. You're also getting the benefits of the proactive patching for a better security posture and built-in diagnosis tooling. In terms of frameworks, we recommend you use either Helidon or Micronaut. So if your app is aligned to the enterprise Java ecosystem, then Helidon's standards-first support for modern Java enterprise patterns through microprofile makes it easy to modernize your existing JEE apps. If you don't have a dependency on the enterprise Java ecosystem, Micronaut is interesting. Micronaut provides you compile time scaffolding. So you get increased performance. More interestingly, you get framework level checking, so you can avoid security and quality issues around reflection and runtime configuration. Let's move on to our second principle. Build your apps as services that communicate over APIs. Rather than a monolithic approach, building an app as a set of independently scalable services that encapsulate specific functionality allows you to make your development team far more agile. So the API contracts between these services provide the mechanism to collaborate on the functionality without depending on the internal details of the implementation of each of these services. So for example, a service can be wholly owned by one development team, and they can freely improve on the implementation without having to coordinate code dependencies with other teams. So begin with a contract-first approach that is based on the business requirement. Describe the behavior of the service, and you can do this using a format that's agnostic to the implementation, like OpenAPI. Then you can prototype that API, let the consumer of the API try it, and then the implementer can make that work. So you've essentially built an iterative way to arrive at consensus. So both the producer of the API and the consumer of the API can be different teams that are working independently of each other. Now, in terms of the technology recommendations here, we already talked about OpenAPI standard. Now, the tooling that goes with that is Swagger tooling. This allows you to generate OpenAPI specification-based descriptions. So you can then use infrastructure as code techniques to manage the deployment of these and version control those API descriptions, along with the backing code that implements those APIs. You should also define policies that need to be enforced for these API interactions. For example, what type of validation do you need to do on these incoming requests? Is there any rate limiting that is a requirement? Do the responses need to be cached? You do these through an API gateway. So the Oracle API gateway is basically a common point of enforcement, and it shields the consumers from back-end implementations. So our third principle is about how you package your applications. Package and ship your apps as containers. Now, containers package your app code and dependencies as one unit, so you can run these reliably across multiple heterogeneous environments. And this makes them extremely portable. So regardless of whether you're running on-premise, or you're running a physical server in the cloud, or you're running a virtual machine, you get the same result every time. So you now have a simplified and consistent approach across development, management, observability, and governance for your app. And because containers run across multiple environments, you're effectively avoiding vendor lock-in in the design of your app. Now, we talked in principle 2 about breaking down the app into services that perform discrete operations. This principle is telling you to package those services as containers. If you have existing apps, gradually replace existing functionality with the containerized versions until you can replace the entire app. So the key technology recommendations that are related to this principle are the OCI Container Registry, commonly known as OCIR, and this allows you to store and share container images, and the Oracle Container Engine for Kubernetes, or commonly known as OKE. And this enables you to provide a fully managed Kubernetes-based container orchestration, which allows you to run these and manage these containerized applications at scale. Additionally, we also natively integrate these services with platform capabilities like logging and observability. Obviously, security is critical as well. So a closely related technology recommendation here is the OCI Vulnerability Scanning Service, because this service enables you to improve the security of the container environment by scanning images in OCIR for vulnerabilities. You can then use the results from these scans to determine whether these containers can be deployed at all to OKE. Okay, let's move to principle 4, automate build, test, and deployment. Now, continuous integration and continuous deployment more commonly known as CI/CD, are a set of tools, practices, and processes that teams use to deliver code changes frequently and reliably, right? And this spans all areas in the lifecycle: code reviews, unit testing, integration testing, check-in processes, filing tickets, deployments to various types of environments, staging, pre-production, production, etc. It also applies not just to application code, it applies to also deploying infrastructure that's underpinning that application. So standardizing the development lifecycle through CI/CD allows you to build in reliability and security in a much more consistent way. So in terms of the technology recommendations here, these are the OCI Artifact Registry, OCI DevOps, and the Resource Manager service. Artifact Registry provides a version control repository that allows you to store and share various types of artifacts that your application is comprised of. So think libraries or zip files or software packages, etc. OCI DevOps is a newly launched continuous deployment service, and this lets you deploy these artifacts that represent your workloads at scale. So you can do really interesting things with this. You can track the history of your deployments. You can set up gates to define the required conditions for deployments. You can roll back deployments if you're failing validations, etc. And finally, the Resource Manager service. This is a fully managed Terraform-based service that automates your infrastructure creation at scale. You just write your Terraform scripts, and the service lets you run those to create your infrastructure. Principle 5 tells you to use fully managed services to eliminate complexity across application development, runtimes, and data management. By using fully managed services that take care of managing infrastructure maintenance, automated scaling, and patching, so the app developer can focus on creating customer value. And the developer gets best-in-class solutions without needing expertise in each of these areas to run and operate their app. They don't have to be experts in infrastructure management, for example. So this principle is exemplified by a broad variety of services at Oracle, and these are represented in our technology recommendations. Reduce the complexity of data management by storing data in Oracle Autonomous Database for transactional and data warehouse workloads, and in various Oracle Cloud Storage services for file, block, and object storage. For low-code apps, use Oracle Apex. Use Oracle Functions for apps that run for a short duration. Oracle Streaming Service gives you a Kafka-compatible event streaming capabilities. Principle 6 is about keeping the application tier stateless. We think you should preserve all your app state in external persistent stores using as few stores as possible. Ideally, you just use one store. Now, what's an app state? There's all sorts of states associated with an app. Some examples of application state are user session state, the page a user was on, shopping cart, etc. There's also user preferences, or the position of the app in a multi-step workflow, the configuration for deployments, runtime configurations, etc. So keeping all of the state external to the application makes the app resilient to failures in the layers below it. So you enable quicker recoverability. You also have the benefit of application state having the same security guardrails as application data. So take encryption. Just like you encrypt your application data, you can encrypt app state as well. One important consideration here is you don't want the data scattered across multiple stores and then run the risk of this data getting out of sync after failures. That's why we say that as far as possible, use just one external store. And we recommend that if you're already using Oracle Autonomous Database for application data, use it to store application state as well. Because Autonomous Database supports multiple formats and types, this keeps things more consistent than using multiple single-purpose stores. If the app does not use a database, then there are other choices, durable persistent stores like OCI Object Storage Service, for instance. Let's move to principle 7. Use converged databases with full-featured support across all data. Now, what's a converged database? A converged, and sometimes it's referred to as a multi-model database. This is something that supports natively different types of data, whether it's JSON data, relational data, graph, spatial data, etc. When you leverage a converged database, a developer can do something like store a new JSON document, insert a relational row, and update a property graph, all within the same asset transaction. They can then use SQL to query, join, filter, and aggregate across all of these types. So they can get the same types of guarantees that they're used to in a relational world. Now, obviously, a big advantage of this approach is reusability. Developers don't have to learn a separate database technology and tune things for various data types, etc. Oracle recommends using Oracle Autonomous Database to deliver on this design principle. You can also simplify the maintenance using views to expose the data in the tables. So you can change the underlying schema and you don't affect existing apps. You should also look to leverage related capabilities like Oracle Data Safe to evaluate and implement security controls. You should use edition-based redefinition to upgrade your apps without downtime. And you should use Oracle Data Guard for HA and for disaster recovery. Okay, so the principles we've talked about so far have covered considerations in each of the individual sort of development, deployment, and runtime areas in the app lifecycle. The next 3 principles really apply holistically across the entirety of the app lifecycle. So let's talk about principle 8, instrument end-to-end monitoring and tracing. As developers build modern apps, failures happen in newer and more unpredictable ways than they might have been familiar with in the monolithic model. So there are so many new types of interactions between the app's components as well. The infrastructure is elastic, so that adds to more failure modes. So it's really critical for developers to maintain an authoritative and timely view of the application's health, the application's performance, the operational state, and any security incidents related to the application. So this will help them make sure that the key expectations on each of these dimensions is being met. And if they're not, that they're able to take action immediately to remedy that situation. The only way you can do this is by instrumenting the app and the infrastructure through the entire lifecycle. So our technology recommendations comprise a broad set of fully managed services covering all aspects of this lifecycle. OCI logging provides a single pane of glass covering infrastructure and application level logs. OCI monitoring provides metrics and alarms that can be used to monitor resources both actively and passively. Log analytics gives you deep analytics capabilities into log data that's spanning application and infrastructure data. APM gives you deep visibility into the performance of your application. And finally, if your application uses Java, we recently launched the Java Management Service. So this enables you to monitor and manage your Java runtimes. And it's doing this by using telemetry data that's sent from the JVM. Principle 9. This is about eliminating single points of failure through automated replication and disaster recovery. So modern hardware is great, right? It's gotten a lot more reliable. But despite that, everything fails, right? Machines, networks, disks, they're all going to fail at some point. In fact, entire data centers may become unavailable because of natural disasters. Think fire, hurricanes, earthquakes, etc. So for high availability of your app, the data on which it relies must be available in the face of this failure. Replication of your data is key to this. Our technology recommendations here involve the use of Oracle Autonomous Database, Data Guard, and Golden Gate for all of your high availability database use cases. So between these, you get active-active replication setup and cross-region replication. Now, Oracle Cloud Storage services for block or file or object storage give you replication across availability and fault domains. And this helps you protect data in the event of machine, network, or data center outages. For disaster scenarios that affect entire regions, Golden Gate, as well as specific features in object storage and block volumes, give you cross-region replication. So you're really covered across each of these failure types. And now finally, Principle 10, implement a defense in depth approach to secure the app lifecycle. Now, security is the most foundational requirement for modern apps. So we really need to apply it across every aspect of the app lifecycle and at multiple layers. It's also really important for developers of the app to be able to add security controls simply, and they shouldn't have to become a security expert to be able to do this. And finally, security considerations need to include thinking about, it's not just about preventative mechanisms, but also detective mechanisms, and then remediation for issues that have been detected. Oracle's technology recommendations span a wide swath of security services to deliver on this design principle because we are trying to protect the entirety of the app lifecycle. Web application firewall limits traffic from unknown locations, so Tor nodes, etc. VCN security groups enforce the minimum reachability principle and provide endpoint isolation. Oracle Security Zone service gives you a way that you can create compartments for your infrastructure resources that are secure by default. So any apps that are launched in these compartments automatically leverage this protection. It's a great example of a preventative mechanism. OCI identity and access management gives you strong authentication and security policies for access control. CloudGuard provides the ability for you to monitor for misconfigurations or anomalous activity. So that's an example of a detection mechanism. Another example is the vulnerability scanning service. So this service periodically scans virtual machines and containers for vulnerabilities from the CVE database. So we've covered a wide variety of services and technologies related to each of the design principles we talked about. Let's put all of this together. So here's a view of most of these services in context of where they fit in the application lifecycle and within the application architecture. So by using these sets of services to follow the 10 design principles, the developer is not only meeting the core requirements for their modern app, but they're becoming more efficient in how they do their development. And this drives significant benefits for the business as a whole. To illustrate these design principles and as a way to validate that we've got the right set, we decided to build a reference app that meets all the core requirements using the technology recommendations that we talked about. We also said it needs to be a beefy enough app from a functionality perspective so we can really battle test these principles. So we've built a patient care system that involves multiple entities, a patient, a physician provider, physician's assistants, etc. And it also involves a variety of scenarios that are involved in patient care: remote consultations, tracking outcomes, calendar event management, using wearable devices to track health data, detecting anomalies from those devices, and then using public data sets to garner information about the community health, etc. So we thought that'd be a great validation of the design principles because we're building an extensive set of functionality and we're also trying to meet all these non-functional requirements that we've talked about. So as part of building this reference app, we leverage specific architecture patterns for various aspects of the app. And it turned out they actually represent a majority, really, of commonly used patterns in any modern app. So just like the 10 design principles we talked about today, highlighting these patterns and then recommending the set of technologies to use for each of these patterns will naturally simplify the decision-making even further for app development. So you'll be hearing a lot more about each of these patterns during the rest of the day today. Thank you for taking the time. I hope this was informative. Wish everyone the best and stay safe. Thank you.